This video is on verifying trigonometric identities, just to give you some extra practice. Remember, coming straight from your notes, if you get stuck and aren't sure where to start or get stuck in the middle, you can begin with the more complicated expression because there's obviously going to be two sides to the equation, so you want to try and simplify the side that's more complex. You can also try changing things to sines and cosines. Typically, they're easier to work with. Another strategy is to substitute those basic identities that we've learned to help your simplification process. You can use factoring, and when you have fractions involved, consider finding a common denominator or multiplying both the numerator and the denominator by the same thing. So let's try one to see what they could look like. So if we look here, we've got a fraction equal to sine squared of x. Thinking about that first strategy, the left-hand side is going to be more complex, so I'm going to choose to start over here. In this case, you might be thinking about a Pythagorean identity because we see those squared signs everywhere. The only issue is that secant squared matches up with tangent. Tangent has a sign in it, but that just seems kind of complex to get started. So if we look a little bit closer, I notice that we've got a fraction with a singular denominator. So what I'm going to actually do first is break that fraction up. So I'm going to have secant squared of x over the denominator secant squared of x. Bring down the subtraction sign, and then we've got a 1 minus secant squared of x. Then if we simplify, same thing top and bottom, this fraction goes to 1. And then a basic reciprocal identity of secant squared of x, secant becomes cosine, so that would be a cosine squared of x. And now we could go to Pythagorean identity because 1 minus cosine squared of x, if we manipulate our sine squared plus cosine squared, that should equal sine squared of x. And there we have it. First one verified. Now, before I begin this one, I want you to take a look and pause the video and think to yourself, what potentially would you, what side would you start on, and what might be your strategy? So if you reflected, hopefully you were thinking that clearly this side is more complex to look at, probably easier to work with, and we've got lots of different functions going on, so perhaps the strategy here would be to change them all to sines and cosines. Now, this one, because we've got a fraction and on the denominator, we've got a potential to build two fractions there. I'm going to kind of break this one apart a little bit. First, I'm going to change cosecant of x to 1 over sine of x. And then I make a big fraction bar in the denominator, changing that to sines and cosines. Cotangent is cosine of x over sine of x. And tangent of x is sine of x over cosine of x. So we've really just at this point made a big mess that we need to start to clean up. Looking at the top, I can't really do much with 1 over sine x. So what I'm going to do is I'm going to focus right now on the denominator, and I'm going to outline that in this pink color. And I'm going to go to work on just that piece so we can kind of get that a little bit easier to look at. So what I'm going to do is find a common denominator. So I'm going to multiply the sine x times the cosine x, which means I'm also going to multiply the diagonals. So when I do that, I'll multiply across, get cosine x times cosine x, so cosine squared of x. The numerator over with sine of x will multiply the two sine of x's together and get sine squared of x, and then our denominator is just the multiplication of the two. So now that still looks a little bit messy, but what we're able to do from here is in the numerator, cosine squared x plus sine squared x, that's our Pythagorean identity, so that all goes to a 1. So now just the denominator of the original expression is a 1 over sine x cosine x. So if I kind of bring everything back together, we've got 1 over sine x in the numerator, and our now more cleaned up version of the denominator is 1 over sine x cosine x. At this point, we don't like a fraction within a fraction, so what we're going to do is take the numerator times the reciprocal of the denominator. So that puts the sine x, cosine x up top and the 1 on the bottom. And what happens at this point, we've got sine x, that can cancel out, and we are literally left with just a cosine x, which is what our end goal was from the beginning. So we are verified. Now here again, I would recommend at this point that you maybe pause the video and consider where would you potentially start. So take a moment and think about that. For this problem, looking at either side, they both kind of look a little bit more complex. I mean, you've got a secant over on the right-hand side that has potential to be swapped out for a couple things, but you've got two fractions with a subtraction in between on the left-hand side. Again, I'm going to start over here and hope that I can create something more simplistic like the -2 secant squared y that we have on the right-hand side. So in this case, I don't know of any identities for sine y minus 1 or sine y plus 1. So I can't really swap anything out, and they're already sines, so switching to sines and cosines is already done for us. So what I'm thinking is let's first find a common denominator. So again, I'm going to multiply the denominators across to the numerators and combine things together. So our new numerator for the left-hand fraction would be the sine y plus 1. We'll bring that minus, and then the next piece we have to be careful because there's subtraction in between. We need to make sure we put this in parentheses because we're going to have to distribute that. So our other denominator was the sine y minus 1. And again, I'm multiplying across to get that new numerator. And then I'm just simply going to write the two denominators together, but I'm not going to multiply them together just yet. I'll do that in the next step. So from here, we can clean up the top. First thing I'm going to do, like I said earlier, is distribute the negative. So that means we actually, we're going to have a sine y, a positive sine y, and a negative sine y. So those two are going to cancel, which means in the numerator, I'm simply left with a positive 2. Now in the denominator, important to remember that when you have two binomials, in this case, being multiplied together, you have to use FOIL. In this case, the trick's going to work where those middle terms are going to cancel, but you can't just multiply any which way you want. So I'm going to write out all the terms, but we're going to see some cancellation. So first we'll get sine squared of y, we'll get a negative sine y, a positive sine y, so there's that cancellation, and then we'll get a -1 at the end. So we'll cancel out those positive, negative sine y's, and we're left with 2 over sine squared y minus 1. Now at this point, I'm looking over at the right-hand side to kind of get my head wrapped around where we're trying to get to, and I need to get a secant squared. Sine doesn't convert to secant, so I'm thinking I need to get a cosine in here somewhere. The problem is that sine squared y minus 1 doesn't convert Pythagorean identity. So the other thing I notice on the right-hand side is the 2 is actually negative. So what I'm going to do here is I'm going to factor out a -1 from the denominator. And what that's going to do for me is it's going to make the sine squared negative and make the 1 positive. So let me rewrite that over here so we can see what we've got going on. I'm going to put the negative out in front. And that means that the denominator is now a 1 minus sine squared y. And that is equivalent to cosine squared of y. So now we've got -2 over cosine squared of y from our Pythagorean identity, which at this point then we can make that -2. And if we bring the cosine squared to the top, that gets us a secant squared, which is what we were after from the beginning. So we are verified. So at this point, what I would recommend is I have one more here for practice. Why don't you go ahead and try that on your own? And then I will go over that one here in class. Good luck.